Hello everyone, welcome back to our channel Nursery to Varsity. In this tutorial we are going to understand SHA-256 algorithm. So as earlier we discussed, the blocks are cryptographically linked. So we are going to first get some idea about what is cryptography, what are its different types, and then we are going to head over to our main topic, that is SHA-256, and get some idea about the properties that it proposes, for example the determinism, one way avalanche effect, and much more. So let's get started. Basically, cryptography involves creating written or generated codes that allow information to be kept secret. So as from this line we can understand that cryptography is a way to secure our messages. How we can secure our messages? There are basically three types. First of all, we have got symmetric key cryptography. Was the initial concept that was launched. So in this technique we have got the same key. We can say it as a single key that is being shared among different users. So the sender will encrypt the data by using this key, and this data as a ciphertext will be sent to the receiver, and then receiver will decrypt the file with the same key. So this is how the symmetric key cryptography works. And then we have got public key cryptography. This was the revolutionary technique. In this technique there are two keys together are used, that is the sets of keys are used. One of them is called as the public key and another one is that is a private key. So in this, the public key may be freely distributed while its paired private key remains a secret. So public key is used to encrypt the file, and then all users who want to decrypt that file should have the private key. So the private key is used for the decryption of the file. And the third one is as important from our point of view, that is the hash functions. So in this hash functions, no key is used in this algorithm. This is the main point that we can focus on, that there are no keys used in this algorithm. The major work through of this hash function is basically this hash function is a mathematical function. This mathematical function is used to generate a fixed length output. So here we can say, we can read this as a fixed length hash value is computed as per the plain text that makes it impossible for the contents of the plain text to be recovered. Okay, so hash functions are also used by many operating systems to encrypt passwords. So this was about the hash function. We can take an example, like we have got our plain text. Now then, using a certain hashing algorithm, we have encrypted our data, and this encryption is done using the hash function, and the output we have received is a fixed length code which can contain various characters which are not readable. They may be readable, but they are not the original text or the original document. So now comes the SHA-256. So the full form of SHA-256 is the secure hash algorithm, 256 bits. So the messages that are the inputs can be variable up to 2 to the power 64 bits. That means like 2.3 exabytes, or they are also can be valued as 2.3 billion gigabytes. Okay, and these are transformed into the digests. That is, the digest is the output that we receive of size 256 bits, and the length of the code that we receive from this SHA-256 is of 64 characters, as I earlier mentioned. This contains numbers from 0 to 9 and the letters from A to F. And the major point that we focus is that no matter the size of input, the output is fixed. No matter what we pass through, if we pass through a single character, for suppose we are passing just a letter A in this algorithm, then also we are getting a 64 length character code. If we are passing a word like algorithm, then also we are getting a 64-bit character code. And if we are like sending the message as complete sentence, then also we are getting the 64-bit out of 64-bit character code. And just to mention guys, these outputs that are generated are actually according to the secure hash algorithm 256. We are going to discuss this algorithm in a practical manner in our next video, so stay updated. Now comes the properties of this algorithm, like what properties this algorithm must possess to work to be like usable in various scenarios, like how it is feasible. First of all, the basic property is the determinism. So the determinism can be confined as any computer in the world that understands the algorithm, the hashing algorithm you have chosen, can locally compute the hash and get the same answer. So what this says is that suppose we have got multiple systems, we are using the same algorithm to encrypt the same data, then we should have the same hash value. So suppose we have got a text file, just imagine we have got a text file, we have got two different systems. If these different systems are using the same hashing algorithm, then the output received by these system must also be the same. So that is the most important and the basic property for such algorithm. The next one is the one way. So the input retrieving must not be possible from the calculated hash, otherwise the whole concept will eventually fail. So as guys, we know that if we are using hashing algorithm to encrypt some data, now the encrypted data that we have received is the 64 length character code, so it must not be possible to retrieve the original text from that 64-bit character code. So this must be the major point 2. Like for example, we have got a text file and we are encrypting it with a hashing algorithm, so this way should be right. But again, with this hash, the hash we obtain, we cannot retrieve the original file. So this is the second major property. And the third one is the avalanche effect. This is the most important one, where the minimal change, like the slight change in the slight change in the data will result in a most like drastic, a dramatic change in our output, that is the hash value we receive. Okay, so a minimal change in the output changes the hash very dramatically. This is helpful when someone tries to give a hit and trial method. For example, if we are using A, if we are encrypting A, then the output we receive is like this CA97 and this all. And if you are using two A's, just two A's, no other thing, then you can see the whole this encrypted value we received is different from this. So in this way we can say how this we can relate this with an avalanche, like how that we get in like snowy areas. So this is how this works. The another property is the fast processing. This is obvious that it is important to have an algorithm that computes the hash in a faster way so as to maintain the usage of such algorithm, makes it feasible for usage. Like the processing time of this algorithm must be fast so as to get our encrypted value fast. Okay, and the last one is the collision, how the algorithm is handling the collision. So what is the collision? We can understand this as, if we know the encrypted value we receive is a 64 character long, so we can say that it is limited. Okay, we might like the number of character strings we can receive are like huge numbers, but they are still limited. But the messages that we can pass through are infinite. We can generate any type of message that we can pass through this hashing algorithm. So there are a very less chances that these collision might occur, like these two strings can have the same hash value. So but this is very less probability of having same hash for two different files. Okay, so from this we can also get the pigeonhole principle. If you know about this pigeonhole principle, that if there are like 9 holes and there are 10 pigeons, then there must be 2 pigeons in reside inside one hole to complete this uh, the passage. Okay, so this might occur when we are creating a text file. We are encrypting a file, like we are encrypting a digital document, and we are receiving a hash. Okay, now if you anyhow get some way to forge the digital document, to forge the same hash, then we can obtain a same digital document. Like suppose we have got another digital document, and if we are somehow able to get the same hash, then we can forge the pirate or the fake document. Okay, so this was all for today, guys. Thanks for watching. Stay tuned, like, share and subscribe, and press the bell icon. If you have got any problem, then you can email us to nur2var@gmail.com.